Hello, teacher. Hello, students. Welcome to today's lesson on operations on sets. Just as we perform operations on numbers, we also perform operations on sets. Union and intersection are the first two operations we will study. We will also use Venn diagrams, which I am sure you have practiced drawing in class. Are you ready, students? Let us begin. I would like you to think about some of the operations performed on numbers, such as addition and subtraction. Now, suppose that we want to add or collect two sets into one set. Let A be the set containing 1, 2, 3, and B be the set containing 4, 5, 6. If we group these elements into one set, the answer is the set containing 1, 2, 3, 4, 5, 6. What if A is the set containing 1, 2, 3, and B is the set containing 2, 3, 4? Please take a moment to write down the new set if we combined these two.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. You might have listed all of the elements one after another, as we did previously. Instead, since some of the elements are exactly the same, you can simply write the set containing 1, 2, 3, 4. You have just performed an operation called union. The union of two sets A and B is denoted by A union B. It is the set containing all elements that are members of set A or set B or both of the sets. That is, A union B is the set containing X, such that X is an element of A, or X is an element of B. If an element is common to both sets, it is listed only once in the union, as we learned from the activity. Let us try another activity. Let A be the set containing 1, 2, 3, 4. B is the set containing 2, 4, 6, 8. C is the set containing 3, 4, 5, 6. Find A union B and B union C. Then find A union B in union with C.
Students, let's get ready. Let's get back to our lessons.
Welcome back, students. Please compare your answers to these. A union B is the set containing 1, 2, 3, 4, 6, 8. B union C is the set containing 2, 3, 4, 5, 6, 8. A union B in union with C is the set containing 1, 2, 3, 4, 5, 6, 8. That was quite simple, was it not? The union of sets has some important properties to remember. For any sets A, B, and C, A union B equals B union A. This is called a commutative property. A union B in union with C equals A in union with B union C. This is an associative property. A union a null set or an empty set will always equal A. This is an identity property. The next operation we will learn is called the intersection of sets. The union of sets includes all elements that are in set A or set B. The intersection of sets includes only those elements that are common to both set A and set B. That is, A intersection B is the set containing X, where X is an element of A and X is an element of B. If we look at this Venn diagram, A intersection B is represented by the blue shaded region. Let A be the set containing 2, 3, 6, 7, 8. B is the set containing 2, 4, 6, 7, 9. A intersection B is the set containing 2, 6, 7. Students, please try this activity. Let G be the set containing 4, 8, 12, 16, and so on. H is the set containing 3, 6, 9, 12, and so on. What is G intersection H? Can you also express the set using the verbal method?
Students, let's get ready. Begin. get back to our lesson.
Hello, everyone. Let us look at the answer together. I hope that you were able to determine that G is the set containing multiples of 4, and H is the set containing multiples of 3. This means that G intersection H is the set containing 12, 24, 36, and so on. Verbally, you can express this set as multiples of 12. If two or more sets have no common elements, they are considered to be disjoint. A and B are disjoint if and only if A intersection B is an empty set. Using a Venn diagram, we can see that there is no intersection of set A and set B. The intersection of sets also has properties that are commutative, associative, and related to identity. For any sets A, B, and C, and the universal set U, A intersection B equals B intersection A. A intersection B intersected with C equals A intersected with B intersection C. Finally, the intersection of A and the universal set will always equal A. In today's lesson, we have learned two of the operations that can be performed on sets, union, and intersection. In our next lesson, we will learn how to perform the difference of sets. Until next time, thank you, teacher. Thank you, students.